Welcome back to another episode of Principles of Micro. Today we are in Chapter 14, learn about supply and demand for resources. So, your book presents the three main factors of production, three main inputs into most firms as being labor, land, and capital. Most books now just do labor and capital. However, I add land back to our story because land has a market that's a little bit idiosyncratic. So look at labor in quite a bit of depth. That's going to be the bulk of this chapter. However, the same ideas will apply to land and capital. So those ideas are going to scale up to other resources. So first we'll look at demand in the labor market. So one thing to keep in mind, for most markets, you guys are on the demand side and firms are on the supply side. The labor market is flipped. In the labor market, you are providing labor, you're supplying labor, so here workers are suppliers and firms are the consumers. The opposite is most other markets where you're a customer and you're buying stuff, you're on the demand side, and the firm that's selling you stuff is on the supply side. So be careful to not get mixed up. Normally you're on demand side, but in labor market, you're a supplier. So one major factor to consider in the demand for labor is the marginal product of labor, often abbreviated as MPL. We learned about that earlier, so let me just refresh your memories on how that works. So the marginal product of labor is approximately the increase in production you get when you hire one more worker. Beware of these common MPL myths. A lot of my students in the past tell me that the MPL is output per worker. That is not true. Once I spent a lot of time dealing with that myth, my students invented a new myth to take its place. Then they started telling me that the MPL is the number of workers per machine. That is also not true. So be careful with that. So we had this example back in an earlier chapter. So when you had no workers, you had no output. Let's say when you had one worker, your output goes up to 20. So that's an increase of 20 from 0 to 20. So the MPL is also going to be 20. If you hire a second worker, now your total output is going to be 36. That's an increase of 16. 20 plus 16 is 36, so the MPL in that case will be 16. If you hired a third worker, now your total output is going to be 50. 36 plus 14 is 50, so your MPL there is going to be 14. Lastly, if you hire a fourth worker, your total output rises to 60. That's an increase of 10, so MPL is going to be 10 in that case. So your book's tables look a little bit different. However, some of the smart work and the Blackboard homework problems are going to look more like this one here. So that's why I'm presenting it while mainly focusing on this format. So here's the format your book does for comparison. So what they do is they put the MPL in between the number of workers. So they have a gap between 0 and 1, and that gap they put the 20 there for MPL being 20. Likewise, when you go from one worker to two workers, they put the MPL of 16 in between those rows. So that's what your book is doing, but again, most of the problems you'll face will look more like this one over here. So this is the one you want to focus on. Now, we also said earlier that the marginal product of labor is subject to the law of diminishing marginal returns. That's that marginal products, including the marginal product of labor, will diminish as you keep increasing labor more and more and more. So here's a graph that illustrates the law of diminishing marginal returns. So when we have 0 workers, we have no output. The first worker we hire gives us a big boost in output. We go from 0 all the way up to 2.5. However, if we double the number of workers we have, go from 1 to 2, that's not going to double our output. Output only rises from 2.5 to looks like about 3 on this graph. So output still went up, just at a slower rate. Likewise, if you go from 2 workers to 3 workers, output's going to rise by an even smaller amount. Looks like it went by roughly a third on this graph. And if you were to hire another worker, worker number 4, you get even smaller increase in total output. Now we told a story way back in chapter 8 for why that was true. We talked about a firm that has workers and computers. So at the start, let's say we have 5 workers and 5 computers. That means originally we have 1 computer per worker, so everyone can work efficiently. If we hire 5 more workers, though, without changing the number of computers, that's going to increase output, but it's not going to double it. If you have 10 workers and 5 machines, now you have 2 workers per computer. Some time is going to be lost because a computer is not always going to be available for every worker. That's going to reduce the overall efficiency. That's why doubling the amount of workers doesn't double the amount of output. Just like over here, when you went from 1 worker to 2 workers, you got more output, but you didn't double your output. Similarly, if you went from 10 workers and 5 machines to now 20 workers and 5 machines, now you have 4 people per computer. That means that there's going to be a lot less efficiency for each worker. That's because if you have 4 people per machine, then most of the time a machine is not going to be available. A lot of times the workers will be effectively forced to go back to the old pencil and paper days. So hiring more workers will probably give you more output, but it's not going to double output. So the law of diminishing marginal returns holds true not just for that one hypothetical factor I told you about, but much more generally. You'll see this being true for just about every firm out there. So output's going to rise, but the curve is going to flatten out the further out you go. Kind of like the coronavirus curve. So you have more and more cases, but it's not growing quite as rapidly as it was before. It's starting to level off. Alright, so enough of the review. Let's go on and look at some new stuff. So the firm's demand for labor is called its derived demand. We call it derived because this demand is derived from the firm's production function and from the market for its output good. So this demand curve doesn't just come out of nowhere. It's derived. It comes from somewhere else. So we'll look at the derived demand for labor in this section, though the same ideas will apply to land and capital in the rest of this chapter. In this chapter, we'll also focus on markets that are perfectly competitive for these inputs. Now, we already addressed the other issue of what markets are not perfectly competitive in a previous chapter. In the chapter on monopolies, I had a final section that was dedicated to something called a monopsony. So what a monopsony is that instead of being one supplier, now there's just one demander. So it's like when there's only one firm that employs people in a small town. Or it could be when the government is the only buyer of military equipment in the U.S. So those are labor markets that are not perfectly competitive. I should say the company town is the one that's not perfectly competitive for labor. So you already saw it earlier, so I'm going to focus on the competitive market case. When markets are competitive, it means that everyone is a price taker. No individual, no consumer, no firm has any ability to influence the price. You got to take the prevailing market price as given. So we have a special name for the price of labor. That's called the wage. So in this context, everyone being a price taker means that no firm and no worker can influence the market wage. You got to take that as given. So the firm's derived demand for labor is going to depend upon three things. So first of all, it's going to depend upon what's the prevailing market wage. If wages are low, that's going to give the firm a greater incentive to hire than they would be if wages were really, really expensive. If workers are very expensive, you're going to hire fewer workers, most likely. It also depends upon what is the price of our output good. So if our output good is getting more and more valuable in the marketplace, then we have a greater incentive to produce it, which means that we'll hire more workers. So one example of that you see happening right now with the coronavirus shutdown. So you have places like Amazon. I was reading they're hiring another 100,000 workers to staff their warehouses. A lot of traditional brick and mortar stores have been shut down, so people rely upon Amazon to get products that are not available at the grocery store. That means that there's a lot more demand for the products, so they have to hire more workers to keep up with it. Maybe it's not the greatest possible example. I'm not sure the price of Amazon goods has really changed so much. Here's a better example. Let's go with this one instead. So the price I've been reading for masks has been going up. So what they've been doing, presumably, is now going to be hiring more workers to produce masks. So that's a better example where the price is influencing the firm's demand for labor. Another important thing that determines the firm's derived demand is going to be the marginal product of labor. So the productivity of the last worker or any additional workers is going to influence how many workers the firm is going to want to hire. So if your next few workers are going to be very, very productive, that gives the firm a bigger incentive to hire. So now we'll look at a simple case. Keep things very easy. We'll first look at what the price is set to 1. Don't worry about that being oversimplifying. We'll see shortly in a couple of slides what happens when the price is not equal to 1. So we're just trying to keep things very easy right now. We'll get more sophisticated shortly. So for notation, we'll use W to mean the wage. That's very common in economics. We use L to mean number of workers. So why is the abbreviation L? That's because L is short for labor. Now, in some papers, just to be clear, L can refer to the number of hours worked. However, more commonly it refers to the number of workers, and in this textbook, we'll stick to L being number of employees. So the hiring rule for the firm, and this is going to be their derived demand, is that wage equals marginal product of labor. And there's some intuition for why that's going to be profit maximizing. We'll go through a similar exercise we went through before. We'll consider what if the wage were not equal to the marginal product of labor. We'll then show for each possible case that whenever the wage does not equal the MPL, then the firm is failing to maximize profit. So let's go through those two possibilities. Case 1, the wage could be less than the marginal product of labor. To make things concrete, I'll just pick some numbers that are consistent with that story. Maybe our wage is going to be 10, and the marginal product of labor is going to be 12. So the firm has to decide, is it good to hire another worker? Is that going to increase our profits or not? So you got to weigh what's the cost of hiring one more worker with what is the benefit of hiring one more worker. If we hire one more worker, we got to pay them a wage. That wage is 10, so our costs are going to rise by 10 if we hire one more person. We got to weigh that against what are the benefits of hiring one more worker. those benefits are given by the marginal product of labor. We said that was 12. So revenues are going to go up by 12 in this case because they produce 12 extra units, and the price of each unit is 1. So that comes to $12 extra. So one more worker gives us $12 more of revenue, but it's going to be $10 more in costs. Well, profit is revenue minus cost, so if our revenues go up by 12 and costs only go up by 10, that means our profit would go up if we hired one less worker. That means that hiring that extra worker is going to be a good thing. It's going to boost our profits, so we should do it. So the key takeaway here, though, is that if it's possible to do something different and increase your profits, that means that your original profit must not have been maximized. If you really had been maximizing profit, that would be impossible to prove. That's what maximization means. You can't possibly do any better. We just showed, though, that you actually can do better. So that means that whenever wage is less than the marginal product of labor, you can't be optimizing. That rules out this case. All right, now I'll turn our attention to the next possibility. What if the wage is bigger than the marginal product of labor? So that could look like the wage being 20 and the marginal product of labor being 14. So once again, you got to weigh what are the costs and what are the benefits with the last worker. Because the MPL is 14, that's telling us our last worker produced 14 units. We assume that price was 1 in this section, so that means that last worker is generating $14 of revenue for us. The costs of that last worker were the wage we paid them, and that wage was 20. So in that case, that last worker is not pulling their weight. They gave us $14 of revenue, but it cost us $20 to hire them. That's not worth it. We could increase our profits by laying them off. Once again, if it's possible to do something different and to increase your profits by doing so, then your previous profit must not have been the best. You must not have been profit maximizing. So whenever the wage is bigger than the marginal product of labor, the firm is not profit maximizing, so we can just rule out that case. Just draw a big X to that possibility. So if the wage can't be bigger than the marginal product of labor, and it also can't be smaller than the marginal product of labor, the last remaining possibility is that they're equal. So that gives the firm's hiring rule when the price is 1. When price is 1, you hire until wage equals marginal product of labor. Now, this analysis was based upon price being 1. I promise to consider the more complicated case where what if price is not equal to 1? What if price is a variable? So in that case, the profit maximizing rule is going to be the following. This will be the firm's derived demand. You want to set the wage equal to the price of your good multiplied by the marginal product of labor. So why is that profit maximizing? We'll first consider the components here. The wage is the cost of that last worker, or the cost of hiring one more worker. The MPL is how many additional units that last worker produces. When you multiply it by price, you can get the dollar value of what that last worker made. So if your last worker makes, let's say, 10 units, and the price of each unit is $2, that last worker is going to generate $20, 2 times 10, $20 of revenue. So price times MPL is the extra revenue per unit, extra revenue per worker. The wage is the extra cost per worker, so you're equating marginal cost with marginal revenue. That's the profit maximizing rule that we learned about earlier. So for terminology, your book refers to price times marginal product of labor as VMP. That means the value of the marginal product. That terminology is a little bit idiosyncratic. I actually have not seen that particular abbreviation, VMP, in any other textbook. The idea, though, is ubiquitous. You will see price times MPL in other books, so be aware of the idea and that it might be referred to by a different term in a different text or a different course. So now we'll look at the graphs for labor demand. So here's an example we had. We probably saw this example earlier in chapter 8, most likely. So if you have no workers, you have no output. And we said if you hire one worker, output goes up to 25. With 2 workers, you produce 40. With 3, you have 50. And with 4, you have 56. So this first graph here shows you total output depending upon how many workers you have. Our second graph is showing the marginal product of labor. So the MPL is the change in total output. So here, total output rose by 25, so MPL is 25. 25 and 15 is 40, so MPL is 15. 40 and 10 is 50. And lastly, 50 and 6 is 56. So to be clear what you're looking at, with total output, it's going to continue to rise, though at a decreasing rate. It's going to start flattening out the further out you go. The marginal product, though, is going to have a negative slope. That's going to keep going down because that's a change in total output. So we saw the MPL is 25 when you had one worker, so I applied that point over here. It was 15 when you had 2 workers, so I applied that point. So the law of diminishing marginal returns is in effect for both these graphs. For total output, it means the output is going to rise at a diminishing rate. For the marginal product, it's going to mean it's going to be strictly decreasing. It's going to have a negative slope. So with that in hand, we can now find labor demand and graph that as well. So for a simple example, let's say that the marginal product of labor looks like this. The MPL starts out at 30 and then it goes down, consistent with the law of diminishing marginal returns. To get labor demand, or the derived demand, you have to multiply the MPL by price. So if our price is 2, what you have to do is just multiply every point in that curve by 2. So our intercept was originally at 30, multiply it by a price of 2, and now it's at 60. And the slope is also going to be twice as steep as it was before. So we had a slope of minus 5. Rise or run is 30 over 6. 30 over 6 is 5, so slope of minus 5. Because we multiplied by a price and the price was 2, now it's going to be a slope of negative 10. And you see it right over here. So rise or run is 60 over 6. That's going to be 10. So that's how you get the labor demand curve from the marginal product of labor. So you see that derived demand still satisfies a rule we learned about way back in chapter 3. We learned about the law of demand. That told us that when a good gets more expensive, people buy less of it. That implies the demand curve always has a negative slope. Labor is no exception. Labor has the same demand that's downward sloping because of the law of diminishing marginal returns. So this is not really a separate subject, but rather a special application of what I learned about earlier in supply and demand. Alright, I have an exercise for you guys. So L is the number of workers. If you have no workers, you have no output. And Q is the quantity that your firm produces. The wage is going to be 20. Remember, if you have competitive markets, the firm is a price taker and cannot influence the wage. So it's going to be 20 no matter what. Your job is to fill in what's the marginal product of labor and also what is the value of the marginal product of labor. Once you have that, then you can figure out how many workers should the firm hire. The price is $5 and let's say it's being sold in competitive markets, so that's not going to change either. So go ahead and pause the video, fill in a table and figure out how many workers the firm should hire, and when you're done, press play. Alright, I'll assume you have figured out the problem by now, so let's go over the answer. So first we compute the MPL. That's the change in quantity when you hire an extra worker. So here quantity moves from 0 to 10. That's an increase of 10. That means MPL is 10. Next, the output rose from 10 to 17. That's an increase of 7, so the MPL is 7. When output goes from 17 to 21, that's an increase of 4, so the MPL is going to be 4. Lastly, output goes from 21 to 24, that's an increase of 3. So that tells us the MPL. Next step is to find the value of the marginal product by multiplying that by price. Mary said that price is 5. So if the MPL is 10, then price times MPL is going to be 50. 5 times 10 is 50. 5 times 7 is 35, so the value of MPL is going to be 35. And 5 times 4 is 20. 5 times 3 is 15. So our profit maximizing rule and our derived demand was we want to find where does wage equal the value of the marginal product. So where is wage equal to P times MPL? That happens right over here. What that implies is that you want to hire 3 workers. As a result, you'll produce 21 units of output. So that's how you can work through examples where you have tables. Another possibility is that you could be given a problem like this one, where instead of being given a table, you're given an equation. So let's say the wage is going to be $16 in this case, and the price of our final good is going to be $10. The MPL is going to be as follows. So your mission here is the same as before. Figure out how many workers should the firm hire. So go ahead and pause the video and work that out before you continue. Alright, I'll assume you have finished the problem by now, so let's go over the answer. So our profit maximizing rule is you set the wage equal to price times MPL. So the price is $10, so multiply that by the MPL. So 10 times 32 over L. That comes out to 320 divided by L. So next step would be multiply both sides by L to get the L out of the denominator. That means you'll have 16L equal to 320. Very last step to isolate, or perhaps I should say in these times to quarantine the L, divide both sides by 16. 320 divided by 16 comes out to 20. So I'll write L star is 20 workers. So about notation, remember star is often denoted for optimal. So the optimal number of workers, the profit maximizing number of workers is 20. That's why I gave it a star. So that's how you can work through problems like that one where we have an equation, we can look at what's going on more visually as well. So the MPL is given by 32 divided by L. So it's going to have this kind of shape like this. So you can see it's consistent with the law of diminishing marginal returns. The MPL is always going down as you hire more and more workers. Now you multiply that by the wage to get the firm's derived demand. This over here is derived demand. So now instead of having 15 over there, multiply it by the price of 10. So now it's 150. 10 times 10 is 100, so that's over here. And 5 times 10 is 50, so you can see how the transformation was made. So what you do visually to find the right number of workers is you look at where is that derived demand intersect the wage, and wage is 16. That should be somewhere down here, so they intersect around 20 workers. Same as our result of the math. So that's how you find a firm's demand at a snapshot in time. Now, of course, over time things can change, and the firm's demand curve might shift depending upon different conditions in the market. So your book lists two factors that can shift the firm's derived demand. So first of all, if demand changes for the firm's product, that can lead to the firm to change its labor demand. We've seen this happen quite a bit in the last few weeks with the whole coronavirus shutdown. Restaurants, for example, are seeing much less demand. They still offer deliveries and takeouts in many cases, but no one's allowed to dine in anymore, and they're seeing less demand overall for restaurant meals. So because there's less demand for restaurant food, that means that a lot of restaurants have been laying off some of their employees or furloughing them. So you can see how that's led to changes in the labor market. Also, the firm's costs change in some way that can cause them to change their demand for labor as well. So here are some other examples. Back in the Great Recession, which I talk about much more in my macro class, but one thing that was going on there was there was a big run up in housing prices, and then housing prices suddenly fell dramatically, and there was a lot less demand for new houses. So as a result, a lot of construction companies that have been hiring workers to build houses suddenly had no need for them anymore. So a lot of construction workers lost their job in the Great Recession. Actually, a lot of people just about everywhere lost jobs in the Great Recession, but it was particularly bad if you worked in construction. So that makes a lot of intuitive sense, but you can connect that and reconcile it with what we established earlier. So earlier we said that the firm's derived demand is price times marginal product of labor. So even though the workers are still productive, their MPL was not necessarily changed by the Great Recession, the price of a new house did fall quite a bit. So if P is going down, then P times MPL also goes down. The value of marginal product of labor goes down. So that's going to mean less demand for construction workers. So here's what that would look like. Here's our old demand curve back here. So L is labor number of workers on the x-axis, just like graphing quantity on a typical supply-demand graph. Wage is the price of labor, so it's like a typical supply-demand graph where you have price on the y-axis and you have quantity on the x-axis. So pre-recession, we had this demand curve out here where firms are hiring lots and lots of workers to make new houses. Once the price falls, that's going to mean less demand for workers, so demand is going to shift back. So the other thing that shift labor demand is changes in the firm's costs. So let's suppose that the cost of new airplanes is going down. We know from the law of demand how airlines will respond to this. If something gets cheaper, people buy more of it. So if airplanes get cheaper, airlines are now going to start buying more and more airplanes. Now, in order to use those airplanes and have flights, you got to hire more workers. You're going to need more pilots. You're going to need more flight attendants. So that story makes sense and can also reconcile to what we learned about earlier. We said the profit maximizing rule was wage equals price times MPL. So how is that impacted when you have more airplanes? Well, it's going to raise the marginal product of labor. If you have just one airplane and you have 4 pilots, then the marginal product of labor is probably going to be 0. You don't need 4 pilots on one plane. You need 1 pilot, and you also usually have a co-pilot if it's a large commercial flight. So maybe you need 2 pilots, and that can be efficient. But once you already have 2 pilots, the marginal product of having a 3rd pilot or 4th pilot or 5th pilot is probably going to be 0 or pretty close to it. Well, because the cost of airplanes has gone down, now I have more airplanes, and now I suddenly have a use for those 3rd and 4th pilots. So I have my first 2 pilots on my first plane that I already had, and now I take pilots 3 and 4, I put them on my second plane, and now they're way more productive because they have their own plane to run now. So the MPL for pilots has risen when the cost of airplanes falls. Because MPL has gone up, that's going to lead to P times MPL to go up. Demand is P times MPL, so demand is going to increase as a result. So that's going to shift our labor demand curve outward. So here's our old labor demand curve. We have wage, the price of labor on the y-axis. We have quantity, L, number of workers, on the x-axis. So old demand's back here, but then once we start buying more airplanes, we have a greater demand for pilots and other airline workers. So demand shifts out as shown in the picture. Now, there's one trap to watch out for here. So your book is right that both cost changes and demand for the firm's product will shift labor demand. Now, one thing that does not shift labor demand is the wage. We talked about something very similar way back in chapter 3 when we talked about supply and demand. We distinguish between a shift of the demand curve, which looks like this, versus a movement along the same demand curve. So in this first picture over here, the same curve is still there. You're just picking out a different point on that curve. So we had some slides in chapter 3 talking about how do you know when you have a shift versus when you have a movement along. And here is our rule for that. We said that if you change price, that always gives you a movement along, not a shift. Why is that? It's because the only reason that caused people to start buying more was because of the price change. So if price were to go back to where it started, my example down here, going back to $5, then demand would go back to the exact same place it began. So that tells you, okay, we're still in the same curve. We're still in the same overall relationship between price and quantity. In the labor market, the price of labor is the wage, and quantity is the number of workers. So a price change in the labor market means a wage change. So just as a price change in the market for goods gives you movement along, so also does a wage change in the labor market also give you a movement along, not a shift. Let's continue our analogy with the stuff we learned about earlier in chapter 3. We said a price change gives you a movement along. If something other than price changes, that's when you start seeing shifts. Back in chapter 3, we had a whole list of things that, other than price, could cause a shift to happen. So we said things like a change in income could cause consumers to buy more, or could cause them to buy less, depending upon the market. We also said that related goods could shift demand. So if things here like, those are one of our examples. We had, hot dogs and hot dog buns. So if there's a change on the market for hot dogs, that's going to lead to shifts in the market for hot dog buns. We also said that consumer tastes, things like fashion, can lead to a shift in demand. Also, price expectations could shift demand. So could the number of buyers, and also taxes could shift demand. So in general, when something other than price shifts, that can cause the whole demand curve to shift. So demand can move out like this, or demand could end up moving back in the other direction depending upon what's going on. So things other than price shift demand. Changes in price alone gives you movement along the same demand curve. So in the labor market, the price of labor is the wage, so a wage change gives you a movement along the same derived demand curve. If you change something other than the wage, so like the firm's cost, or something like the market for the firm's final product, that's when you get a shift. So it really boils down to, is a change caused by a wage change, or is it caused by something else? That's how you know if you're going to shift demand or not. Alright, that wraps up our section on demand. So be sure to tune in for our next episode where we learn about supply.